plastic bag is full, we throw it into the nearest landfill. It's out of sight and out of mind. What is the state of our humankind? And I don't know what to say, 'cause we produce more every day, and we call it garbage.
I have a hard time accepting the fact that the pollution that we see here in the Don River is as a result of carbon emissions or my SUV. I have a hard time. I also have a hard time accepting the fact that reducing my carbon emissions is actually going to clean this up. The banks of the Don River, very similar to the Humber, you know, we've concreted and essentially turned them into a sewer. And if you look, you can see, you know, the Don Valley Parkway over top here. You can see the rain catch basins up top, and the water comes down the downspout, and of course there's not a carbon filter, there's nothing on the end, it just goes right into the Don River. I mean, I guess, is it too far gone and we've just given up on the Don? This is like, in the last century, everybody in the city of Toronto's been on a huge bender drinking, and this is the result of that 100 years of drunkenness. And this is what we've got to deal with, and now we're hungover, the party's over, and we got to clean this mess up, folks. This week on Going Green for Green, we're going to recap some of the previous episodes and try and explain the reasons behind the topics that we have covered so far. In our first episode, we discussed brownfields. The term brownfield is kind of self-explanatory. It is basically land that has been contaminated by industry that previously operated on the site. Brownfields are important because the contaminants in the ground can travel through groundwater and leach into our lakes, rivers, and streams. Remediation techniques and technologies have come so far that we can now fix and remediate sites that 20 years ago were considered impossible to clean. If we want to save our lakes, rivers, and streams, remediating brownfields is a huge part of the solution.
Basically, brownfield development is it's kind of an unmined jewel, I guess. And the problem with it in the past is that the remediation of the site wasn't worth the value of the site. So the government a few years back put in a program that they would give you a tax incentive to actually clean the site. We've done a number of small brownfield development. I have property that we've done bioremediation with microbes, which works in certain instances.
And those microbes actually, it's like microscopic bugs.
Yeah, well, these microbes, they can't go, they're not like a bloodhound, they don't go find oil. You know, these are very, very small microscopic organisms. So you basically drill a well and you put your microbes in and you'd follow the groundwater delineations. So the microbes actually travel through the groundwater, yeah, and then basically eat the waste. They digest. They digest and convert the hydrocarbons into a non-toxic form. So the problem is, and a hydrocarbon would be like, so if gasoline, right? You know, there's corner gas stations that had the underground oil tanks all over the city of Toronto, all over the province for that matter. They sit undeveloped, and basically, you're telling me that we can inject microscopic bugs that would eat that as contaminants. Yeah. The problem with that is that it's stuff. Well, it's amazing. It's sort of like it's not as amazing as it sounds, because it only works well with very, very specific types of soils. It wouldn't work well if you're in southeastern Ontario, where we have a lot of St. Lawrence clay. If you have contaminated clay, how are you going to push water through it? Right. It doesn't, you know, that's the nature of clay, right? It prevents water movement. So if you have contaminated soils, you're never going to be able to push microbes through it. So you can use other technologies. You can use passivation, which is a very interesting technology, using hydrogen peroxide. You can do the traditional dig and dump, where you dig the material up and send it to landfill, and use it as cover. You can also bioremediate it by moving it and putting it in a system like the Gore system and putting air through it, and using a microbe and continually turning it. Every site is specific, Michael. For instance, you have a site that is where they used to make batteries, for instance. You have a lot of lead contamination. Lead is a heavy metal. It's been designated as a dangerous substance in terms of human beings and plant and animals. And how do you remove a heavy metal from a soil? Like, people have this misconception that heavy metals can disappear. They can't. They just change forms. So you need to put a process in, whether it's on site, where it's a little bit easier in terms of regulation to treat on site, but it's more difficult because you got to bring all the technology to the site, and you may not have the site size to be able to deploy the technology that you need. Or you take the material and you bring it to a processing facility that can treat a lot of that waste and then reapply it.
Check us out online at www.goinggreenforgreen.tv or follow us on YouTube, Facebook, and Twitter.
Going Green for Green is brought to you by Ontario Electronics Stewardship, and recycleyourelectronics.ca.
In episode 2, we discussed organics, and we looked at the two types of organic processing currently in play. 1, anaerobic digestion, and 2, aerobic digestion, which is compost. The City of Toronto currently operates an anaerobic digestion facility which can make energy from your green bin food waste. We're here at the tipping room floor at the Organics Treatment Facility, CCI's facility in Toronto. And the odor is really overwhelming. And you just get a sense of how important odor management is. Later on we're going to be looking at the biofilter, how this odor is dealt with, and how this facility operates with just really what is, 1 complaint a year during its operation. It's pretty amazing. Anyway, I got to get out of here.
This facility can process about 40,000 tons per year of the City of Toronto green bin waste. To put that in perspective, that's the equivalent of about 160,000 homes of the 510,000 single-family homes that are implemented with the green bin program in the city. So the waste gets dropped at the tip floor and then it gets loaded onto an enclosed conveyor. We can enclose the conveyors to manage odors. And you can see in here now that the waste is being loaded into the pulper. So after the pulper's gone through its routine, we pump off the organic pulp here in this component. And at the same time, we're also removing the heavy fraction, the glass, the household batteries, through this sieve trap system here. This pulp then goes over to a degritting system to remove the fine grit before it's sent to the digester. So once that pulp has spent its time in the digester, typically from 14 to 21 days, it's then removed and it's sent to these dewatering presses where the liquids are squeezed from it to create a solid. So once the digestate out of the digester has been put through those presses to dewater it, the liquids are treated and returned to the sewer, and the solids end up in this trailer here to be taken to make a final compost product. So our company developed 2 facilities here in Ontario. We're here at one today, the City of Toronto Dufferin Organics processing facility. And within this facility, there is a process implemented called the BTA process. That's the technology that our company has the rights for here in North America. And there's 2 major components to the process. In the building here, what you'll see is the first step, which is wet pretreatment. So when the city collects all of our green bin waste, it's delivered with a truck into that facility, and that's where the contaminants are removed and where the remaining organic fraction is pulped and created into a slurry. That slurry is then pumped off and put into this tank. This is actually the digester, as we'd mentioned earlier, works like our bodies and digesting our food. Within that tank, the organics are broken down into those 3 components: solids, liquids, and gases. The gas, as you can see, is captured and it's immediately available to create renewable energy. And that can take multiple forms. That could be cogening the gas that's created to create heat and electricity. That gas can also be used to create a high-grade natural gas that can actually be put in the pipelines. The other alternative is to also take that gas and make a liquid fuel. In the case of City of Toronto, the potential to power the municipal vehicle fleet using the waste from the curbs that we all put out. Several challenges when it comes to the diversion and processing of organics from a municipal waste stream. The fact that it's highly liquid requires different processing methods, and the fact that there will be inert contamination in the waste stream, irrespective of how well we do it at the curb and in our homes. Those are contaminants that will still need to be managed. You can see a meat wrapping, you can see a can, a household battery. So it's very important to remove those contaminants. In our case, we do that up front so that we can maintain the downstream product quality in both biogas and the solids, which are typically turned into a compost product.
Going Green for Green is brought to you by the Royal Bank of Canada.
Anaerobic digestion also plays a role in landfills, in that when the landfill is capped, methane gas is created inside it. Now we are harnessing that gas and creating energy from landfills that have been capped and forgotten long ago. Landfills, landfills, landfills. Horrible, horrible, horrible human behavior. Not much we can do about it. They're necessary evils. What are we going to do? We're consumers. We just can't stop it. So you got to start looking at our waste as a resource. And at Walker, they're doing a good job of it. This is incredible. Everything you see here is landfill. We're on a 500+ acre landfill site.
We've had a landfill at our Niagara Falls location since 1982. We do take a lot of IC&I, industrial, commercial, institutional waste from the City of Toronto here, and we do get organics through that system. We get a lot of paper still, which is unfortunate, but it still shows up in garbage quite a bit. And all of that material will break down in the landfill and create landfill gas.
I hate landfills. Who doesn't? But you know, you gotta give these people credit. 22 kilometers of piping and a network of fittings that actually go into this ground here, drawing from 80+ wells, all that get sucked into this little facility just down over the hill over here. And it creates 4,500 cubic feet per minute of biogas. 3,250 CFM, cubic feet per minute of that gas, is tripped over to Abitibi Bowater, where it's used in the recycling of the newsprint process. Now they have the flare, that little stack that you see just over here. Some days the earth gets heated up and it starts shaking and moving around, the water comes into the ground and they get excess gas, boom, that flare goes off and it's a protection. It's kind of like a release valve if too much gas is created, okay? 4,500 cubic feet per minute of biogas. I could talk to you about gilojoules and all kinds of weird terminology, but I'm gonna simplify it for you. Basically, you're looking at enough gas to power 15,000 homes. Leadership in Energy and Environmental Design, in other words, the LEED program, is changing the way construction companies build their projects. We spoke to Jeff Smith, the CEO of Ellis Don, to try and find out how Ellis Don is changing the way they build their projects to achieve LEED certification.
I think it's an accurate premise that developers and construction companies have been insensitive to environmental concerns up until very recently. They weren't the enemy of the planet, they just weren't thinking about it. And I think we were all too concerned with short-term cost versus not just long-term environmental impact, but long-term return on the investment in energy savings and waste recycling and that kind of thing. But over the last 2 or 3 years, it's gone to the top of their priority list. The value of their buildings is affected now. Plus, these are good people. People want to do good things for the planet. They just didn't know how. And now it's the first thing that everybody asks us at the beginning of the design and construction process. How do I get LEED Silver? How do I get LEED Gold? What can I do? What's involved? I read a stat that 35% of the solid waste globally is generated by the construction industry. So that's the first place we've got to make a dramatic change. On the Child Development Center in Calgary, we were able to divert 78% of the waste from that site away from landfills into recycling opportunities. So as you can see, that's a dramatic impact. There are about 58 different levels of design and construction process that you've got to hit to get a LEED Platinum accreditation. On the Child Development Center, we hit all 58 of them. There are different levels of LEED. The main ones are silver, gold, and then platinum. All of them deliver dramatic increases in efficiency of the building in terms of energy use and decreases in terms of wastage being created by the construction process. You can get to a silver LEED rating for your building, which means the building is more valuable, better to work in, and much better for the environment if you plan it properly for a zero cost. To get to a LEED Gold rating, which is a really dramatic savings on both of those, both waste and energy, I think it's about a 5 or 6 or 7% increase in construction costs, but it's more than paid back over the life of the building, even in the first 5 to 10 years of the life of the building, in energy savings and other efficiencies. Platinum is a little more. Call platinum about 10, 12 percent. Again, more than paid back, but it does require that upfront investment.
You're looking at basically, if you invest up front, you're looking at 10 years to recoup your costs and actually start to see savings on going LEED Platinum.
If you're talking about LEED Platinum, I think that's fair. If you're talking about LEED Silver, as I say, which again is a terrific improvement, it's zero.
Going Green for Green is brought to you by Ontario Electronics Stewardship and RecycleYourElectronics.ca.
The Green Energy Act and FIT, or the Feed-In Tariff Program, is all about empowering the individual so that they can become their own power suppliers. We spoke to Deb Doncaster from the Community Power Fund to find out more about FIT and the Green Energy Act and what it means to you, the individual. Here we are today with Deborah Doncaster, who is the head of the Community Power Fund and is really a driving component in renewable energy and in the Feed-In Tariff Program, which is being discussed today at First Canadian Place in Toronto. Deb, thanks for taking the time to chat with Going Green for Green today. Give us a little rundown. Tell us your history. Deb's also responsible for the big windmill on the waterfront, one of the first ones in Canada. So she's got a long history here, and she's going to sum it all up for us in a couple of minutes.
Okay, I'll do my best, Mike. Thanks for having me on the show.
No problem.
Well, I started my career in renewable energy about 12 years ago with the idea of building a community-owned windmill on the waterfront. And the energy market was about to deregulate in Ontario that would allow for new forms of ownership and new generation technologies to come in. So it was an opportunity for communities to do projects as well as do windmills and not just coal plants in Ontario. So the biggest challenge was who do we sell our power to? So we initiated a campaign for a feed-in tariff, which is the mechanism used in most European countries to drive renewable energy. So rather than competing for a contract, if you meet all the milestones of developing a project, anybody can get a contract and feed power into the grid and be paid a reasonable return on investment. So the key is you say, our grid is open for business. You provide priority access to the grid for renewable energy technologies, and you guarantee the right to connect. So the grid access issue is the first component, and then the second component is, and I will pay you on a 20-year contract, the cost to build your project plus a reasonable return on investment, and that's what I'll pay you for every kilowatt hour of electricity you put into the system. So it allows a homeowner to put up a solar panel, a farmer to put up a wind farm, or a private sector company or utility to put in a mega project, and they all are under the same rules and make the same return on investment. So we put our heads together and said, let's push for a Green Energy Act for Ontario that would deal with the grid issues, deal with the permitting issues, and deal with the procurement issues that weren't working under the current FIT program. What's the cost to put that project in the ground, and what's a reasonable return on investment? And so you set the tariffs, generally speaking, for, let's say, for example, for wind, you'd have an onshore wind category, and then you'd have an offshore wind category. For solar, you'd have a residential price would be different than, say, a large wind farm or a large solar farm, where there'd be an economy of scale for doing a bigger project. So each project gets a different tariff depending on size and capital costs.
Is this the best we can do? Of course not. We can do better. Think about it, centralized power. So we build these massive power plants that produce power, and then we have the distribution grid, which, the hydro lines carry that power to where it's needed. It's kind of crazy. Certainly back in the day, it was the only solution that we had. But now, as we're looking at solar and wind and all these alternative energy uses, you, the individual, has to become your own power supplier. And if you can produce enough power to do 3 loads of laundry a day and watch TV for 3 or 4 hours a day, great. If you can't, let's hope that we learn how to live within our means, because that's what it's really about. Swim, drink, and fish. That's the brand of environmentalism that Mark Matson practices and preaches. He is the founding member of the Waterkeepers in Canada. Of course, the Waterkeepers being Bobby Kennedy Sr.'s organization that started in the 60s in an effort to clean up the Hudson River.
In the 1970s with Earth Day, the first Earth Day, it was, one of the largest protests in Western democracy, where people took to the streets and said, enough's enough. Like, we can't be cut off from our water and have drinking water and no fish and no air to breathe. So they passed a lot of laws, like here in Ontario, the Ontario Water Resources Act, the Environmental Protection Act, gave meaning and force to the Fisheries Act, which all said to Canadian citizens one thing and one thing only, that we will protect your right to clean water so you can safely fish, drink, and swim. So under Ontario's Environmental Protection Act, it says nobody can render the environment unfit for whatever use can be made out of it by you. You know, for me, it's a failure of our laws currently that you can't go to Lake Ontario, one of the 10 biggest lakes in the world, and catch a fish and eat it. I mean, nobody does it. It's a strange thing that we just assume that this great lake in the world is, you know, dead for all intents and purposes from giving us food. It's a tragedy.
Today on Sustainably Speaking, we find ourselves back at the boardwalk at Ashbridges Bay. Today we're talking to the folks that we meet about the Lake Ontario, their relationship with the lake, whether or not they swim in Lake Ontario, whether they eat the fish from Lake Ontario, and how important the lake is to them in their life here in Toronto. Have you ever swam in Lake Ontario?
Yes, recently, yesterday I did.
No, never have.
No, never have. Like my mom tells me not to because she says like you can get ear infections and like eye infections, but like I do it anyways.
I have swum in Lake Ontario. It's nice and refreshing. You go down on like a hot day or something and you just need it sometimes.
And do you guys ever eat fish from the lake?
Not that I know of.
Yeah, I don't think so.
No?
My dad always comments on how the fish would glow in the dark at night, but he's usually joking, so I probably would eat it.
Yeah, I would eat it.
What can you tell them about how we should treat this lake?
Not to pollute it, take advantage of it, swim more. It's cleaner than what we've been led to believe.
You can't swim on these days, so a lot of people are like, oh, I don't know if I can swim today. I don't know if it's a good idea. So it's just kind of built up that stigma that I guess people have.
When you talk about your generation using the lake more, why do you think that is?
Probably because our parents didn't use it as much and we kind of want to take advantage of it now and we want to protect it for our kids and future generations because we realize how much fun we have whenever we're down here and we want our kids to experience that as well.
Here's how it works. On the Humber River here, you know, we're standing on a concrete wall, and basically this retaining wall runs all the way up and all the way down the river. And in the 30s, they filled it in, and they filled it in to create these nice walking trails. You know, we've done what we've done, and I wouldn't want to give up this park for anything. So, you know, it's beautiful. But my problem is with this water. It is so polluted. You know, mercury, PCBs, dioxins, furans, terrible, terrible stuff in there. And the fact of the matter is we can clean it. Is it going to cost money? Yes, it's going to cost money. It's going to take manual labor. It's going to take trucks and equipment and bulldozers, and it's going to be hard work. But the fact of the matter is we can do it. And I got to think that, is this the best we can do? Is this the best we can do? In the coming episodes, we're going to spend more time looking at the Great Lakes and see how remediating brownfields, diversion at the curb, how all these things can play a role in fixing what plagues our Great Lakes.
Another plastic bag is full. We throw it into the nearest landfill. It's out of sight and out of mind. What is the state of our humankind? And I don't know what to say, 'cause we produce more every day, and we call it garbage.